Okay. Sure. As long as you bring them back. Okay. Not like your calculator yesterday. No, it's more for like notes. More for notes. All right, you guys, here we go. Talking about what we did on Tuesday. This was on Tuesday. It's gonna be all messed up. Tuesday. We were multiplying monomials times monomials. Remember, monomial is just like a one thing times a one thing, right? Monomial times monomial. And the rule when we're multiplying monomials is we first multiply the coefficient. What is the coefficient? What is the coefficient? It's, yeah, it's like the big number out in front, right? It's in front of the variables. So yes, exactly, Jamie. I multiplied 3 times 2, and that gives us 6. Excellent. Okay, and then I add the exponents for variables with the same base. Okay, so I've got a squared and a to the 5th. Those have the same base. What's their base? A, right? So I have a to the 2 plus 5, which is, so 6a to the 7th, right? So I multiplied the numbers in the front, and I added the exponents of all the a's. But if I have something like, let's look at number 2. We'll do number 2 together really quick. So again, I'm going to multiply my coefficients. What are my coefficients? Huh? Yeah, 6 and 3. What's 6 times 3? 18. Okay, now I saw a bunch of people today, they wanted to add, okay, 1 plus 3 plus 1 plus 1, and then they just picked one of them and said z to the 1, 2, 3, 6. No, that's not it. We need to add up all of our x's. So I've got 1x here and 1x there, so x to the what? X to the second power, good. And then I've got how many y's here? 3. Do I have any y's over here? No, so I'm going to take y, and it's going to be to the 3 plus 0. So just to the third, right? And then, do I have any z's over here? But how many do I have over here? 1. So then in total, how many are there? 1. So I can write z, or I could write z to the first. Okay, does that make sense? That's okay? Cool. All right, so that's what we learned on Tuesday. Now let's talk about what we learned yesterday. So yesterday we took monomials, right? That's one thing. And now I'm multiplying it by a polynomial. That's what we did yesterday. So in this example, I'm taking a monomial and multiplying it by a binomial, right? It has 2 terms. And we need to use what's called the distributive property to do that. What is the distributive property? What does it mean? Exactly. I take this 3a cubed and I'm going to multiply it by, oops, I don't want to do the highlighter. I want to do a pen, a green pen. I want to multiply it by the 2a to the 4th. And then I'm going to take that 3a cubed and multiply it by negative 4a to the 5th, right? Again, I take 3a cubed and I multiply it by 2a to the 4th. And then I take 3a cubed and I multiply it by negative 4a to the 5th. So now I have like 2 multiplication problems here. I got to simplify this. But it's the same rule as before. I take my coefficient times my coefficient. So 3 times 2 gives us what? 6. And then I look at my a's. I've got a to the 3rd times a to the 4th. So my base is a, right? And I add 3 plus 4, that's 7. So 6a to the 7th plus, good, negative 12, right? 3 times negative 4 gives me negative 12. And then a to the 8th, right? 3 plus 5. So a to the 8th. Is that okay? So we're just distributing the term out in front to every part of the parentheses. Let's do another example down here. Yeah. Can we combine those two things together and do 6 minus 12 and get negative 6? Why? Who says yes? Why do you say yes?
Because they're both just you can add it, like the exponents when it multiplies.
So the variables are the same, correct? I've got a and a, but this is a to the 7th, and this is a to the 8th. So they don't have the same exponents, so they're not like terms. It's like taking $1 and a peso. I can't add them together and have euros. No, it's $1 and a peso. They're different. A to the 7th is different from a to the 8th. Now, if I wanted to multiply those two things, that's fine. I can multiply them. That's okay. But I cannot add them together. I can't subtract them together. Does that make sense? Okay. Okay, let's pick one to do down here. Let me pick one that's been throwing people off all day. 4? 7?
Let's do 8.
Yeah. 1 is easy. You can do that on your own. I want to do 4. I like 4. Let's do 4.
Oh,
okay. After 3. Right? So I'm going to take this 7x, and again, I'm going to multiply it by 6x. So 7x times 6x, I do 7 times 6, which is 42. And then x times x? X squared, right? I have 1x here and 1x there, so that makes x to the second. Yes. So here, but not 4xy, because I got to do 7x times 4y. So 28, and I have 1x here and 1y there. So it's 28xy. Did you have a question? No. You sure? Okay. Okay, good. Cool? All right. So that's what we learned yesterday, was doing the distributing. And now today we have something else. This is fun. I like doing this. It's my favorite. So let's flip over to the other side. And we are taking binomials and multiplying them by binomials, right? 1, 2 things, 1, 2 things. So it's a binomial times a binomial, okay? Yeah, so not with me. No, I haven't done this with you guys. Yeah, you can do it that way. There's many different ways to get to the same answer. I'm going to teach you 2 different methods. So the first one is the FOIL method. So FOIL stands for something. What do you think it stands for? Each
First. Last.
Yeah. Man, that wasn't as fun as my other classes because we were coming up with like really random things like first.
Often is late.
That's it. That's a good one. Good job. Thank you. Okay. So looking at these 2 binomials here, what would be the 2 first terms? The 2x and the 3x. Okay, so this is where the little rainbow thing comes in. I'm going to do 2x times 3x. What's 2x times 3x? Good. 6x squared. Right? 2 times 3 is 6. 1 plus 1 is 2. 6x squared. And what are the 2 last terms? Good. 7 and negative 5. So I'm going to do 7 times negative 5, which is what? Good. Negative 35. All right, and then we've got our outer terms. Which ones are the outer terms? Very good. 2x and negative 5. Yeah. Okay, so 2x times negative 5 is negative 10x. And then my inners would be what? Yeah, the 7 and the 3x. And what's 7 times 3x? 21x. That's it. Okay. And so I have all of like the parts of my answer, but I need to combine them all together. So it's 6x squared minus 10x plus 21x minus 35. And if I was just doing these problems, I wouldn't write it all out like this. You can write it all out like this, but I would just skip immediately to this step, right? I would do, okay, 2x times 3x, 6x squared. 2x times negative 5, negative 10x. 7 times 3x, 21x. 7 times negative 5, negative 35. Okay, so I go right to this step, but then I can simplify this part. How can I simplify this? Yeah, why can I add these two together? Yeah, same letter with the same exponent, right? Good. These are like terms. So I've got 6x squared, and then what's negative 10x plus 21x? Yeah, positive 11x, and then minus 35. And that's it. That's your answer. What do you think? Okay?
Now this, that scared me. I looked at them like, what?
It looks more confusing than it is. Again, this part, I'm like really breaking it down to show you this. You don't have to do this step. You can go right to here. Again, I look at my first times first. First times first gives me 6x squared, right? 2x times 3x, 6x squared. And then my outer times my outer would give me negative 10x. My inner times inner would give me 21x. And then my last times last is negative 35. So you'll always end up with 4 terms at first, and then usually, most of the time, not all the time, but a lot of the time, you'll be able to combine the 2 middle terms, and you end up with a 3-term answer. Is that okay? What questions do you have? So I can show you the box method as well. Let's look at the box method. So for the box method, you got to start by drawing a box, obviously, and it needs 4 squares, right? 1, 2, 3, 4. And I need to place the binomials on the outside of the boxes. So I'm going to take 2x plus 7, and I can put it on top. Oops. 2x plus 7. And it doesn't really matter. I could put it on the top or I could have put it on the side. And I'm going to take 3x minus 5, and I'll put that on the side. And it's really the exact same process, just kind of a different way of organizing it. What's up? Yeah, that's what someone else said earlier too. It is kind of like a Punnett square. So you look at 2x times 3x. What's 2x times 3x? 6x squared. 7 times 3x? 21x. 2x times negative 5? Negative 10x. 7 times negative 5? And where are your like terms? Yeah, the 10x and the 21x. Those two combined together give us 11x. Okay, so now I have 6x squared plus 11x minus 35. What do you prefer? All right. I got a couple of FOIL. Everybody has said box method all day long, but I like the FOIL method better.
It's easier to process.
Yeah, we're all,
It's all one thing, and then the other one's like a lot of.
yeah. And again, for this, you don't have to write all of this. You could just skip right there. Yeah, but you all have dry erase boards, so you could just draw a box one time and write it in there and erase as you go. So if you want to do that, you can. And we all think differently. If the box method makes more sense, then use the box method. If the FOIL method made more sense, use the FOIL method, right? If just drawing little rainbows on there, I mean, that's really the FOIL method, but if that works, do that, okay? Right. What other questions do you have? Anything else? Okay, we're gonna get some practice in. I want you to work on all three.